Okay, so we're going to go over how to keep factoring higher degree problems and problems that are like x to the third power. And we've just been saying, and even on our bell ringer as we're going over it today, we've been saying to keep looking for greatest common factor. You should try to look for that first in every problem. Greatest common factor. So we're going to continue like looking for greatest common factors in every problem, and we're going to learn new formulas, sum and difference of cubes formulas. And then we're also going to do a little bit of factor by grouping. So you can see the different things we're going to learn on this paper here. So first, reminding you, always keep looking for greatest common factor. So if I'm looking at this problem, do you see, is there anything they have in common? Yeah, so you want to divide everything by x first. So I divide by x. You always have to write that down then. It doesn't just disappear. You have to write that out in the front. So if I divide by x, then I'll be left with x squared minus 4x minus 5. Then after you've done the common factor, then there might be something else. After you've divided by the common thing, then you can see here I have a trinomial. Then this is a trinomial. And we already know how to do those. We were just doing some on our warm-up on our bell ringer. Then you have a trinomial. You can make an x. The last number is -5. The middle number is -4. So what's going to work to factor this? So what numbers multiply to make 5? 5 and 1. Then try to think of like which one's negative, or are they both negative, or think of the signs. How's it going to add up to -4? Yeah, make it -5 plus 1, then that's -4. So that first x has to stay out there. That's the first thing we did, was we divided by x. And then we have finished this trinomial. We figured out it's going to be x minus 5, x plus 1. Now it's done. Now it's factored completely. That's it. It doesn't say solve. These are going to say factor completely. If I was going to solve it, you would get 3 answers, because this is x to the third power, so I'd get 3 answers. My 3 answers would be x equals 0, x equals 5, and x equals -1. See how the answers would be like opposites of these, and this one would just be x equals 0. So there's 3 answers to this thing, but it doesn't say solve it, it just said factor it. We're just factoring right now. Yeah, if I was going to solve it, I'd get 0, 5, and -1. I'd get 3 answers. Okay, the same thing over here, another one where make sure you look for these greatest common factors first. What do you think? Do these have anything in common? Yeah, they all have like letter Y's in it. And look at the numbers too. Is there like anything you can divide? Can you divide them both by something? Well, the first number's a 3. Can you divide 48 by 3? Yeah, you check it out. 48 divided by 3. So yeah, I think the greatest common factor this time, you said y to the third. Good job. It's 3y to the third on this one. So both of these you can divide by 3y to the third. And sometimes people have trouble getting the greatest thing out. Like sometimes people forget about the 3. Some of you just might have started with y to the third. I'm like, uh-oh. See, you got to like divide by the greatest thing you can find. So look at the numbers too. So we divide by 3y to the third. So then that leaves us with what? Y squared minus 16. Okay, now it's still not done. So what I was going to say now is that if you look at this, it's a difference of squares. So it can factor even a little bit more. So we took out the 3y to the third, we got that part. But the y squared minus 16 thing is a difference of squares. The word difference means subtract. So it's a subtraction, and squares means like perfect square numbers. So do you know how it breaks apart some more? Yeah, like plus 4. It's happened as a y this time, but that's okay. Yeah, like y plus 4, y minus 4. That's it. Now it's done. Now it's finally done. So yeah, this chapter tells you to factor things completely. So it's not just one step. There's several steps to these. All right, so we got the first two done. Now the next part is called sum and difference of cubes. And the formulas for those are over here on the side. This one's a subtraction one. This problem, this first one we're starting with. Subtraction is called a difference. So this one's called a difference of cubes. And then the second problem we're going to do, you can see, is addition. That one's called a sum. Addition is sum. S-U-M, sum of cubes. So there's two little formulas. The formulas almost look the same. Here's the two formulas. They're over on the side, on the right side of your paper. So these are kind of interesting. They give you a problem that's like short like this. I'll highlight it in yellow. And then you're supposed to break it apart into this long thing. I'll underline in green. So a short little problem like this turns into this two parenthesis thing. And it's a pattern to it. It's like something to the third power minus something else that's cubed to the third power. And it ends up being a minus b. And then the second parenthesis, a squared plus ab plus b squared. And so the ones that start with minus, the parenthesis here starts with minus. It goes minus plus plus. Remembering how the signs go. This one's minus, so it goes minus plus plus. But if it starts with an addition, it's like the same formula, but this one's addition, then it goes plus minus plus. You have to kind of look at how the signs go. It's the same little pattern with the A's and the B's, but the sign's different. Plus minus plus, but this one's minus plus plus. Look at the signs, how they're different. Similar, but a little different. All right, so we're going to try this pattern on these problems over here. It's really not that bad. If you look at the number 125, this is called third power. That's called cubed. You know, third power is called cubed. So to figure out, you're trying to figure out what number to the third power makes 125. You're trying to figure out, you know, cubed means third power. So like what number to the third power makes 125? So you can take the cubed root of 125. It's like a square root, but you have to find that key on your calculator. You hit 3, and you hit the second key. It's above the square root key. It's like the caret key. It's the up arrow. It looks like that. 3x square root. See, it looks like that with a little x by the square root, and then it's 125. What's the cubed root of 125? Yeah, it's 5. It means like 5 times 5 times 5 makes 125. See, I can show you. 5 times 5 times 5 is 125. It just means like you're finding 3 of something that makes that number. So this 125 is like the second part of this equation. The formula over to the side said a to the third minus b to the third. So I was trying to get you to figure out what b is. B is actually like 5. That's b. That's b. Like in the formula off to the side, that'll be b. So the formula that I underlined in green says a minus b. So it's just going to go a minus 5. The cubed root of 125 was 5. So it's just going to go a minus 5. Just takes a little getting used to how to do it. Now, what do you think comes next? What should I write next? Do you have a guess? A squared. It says a squared in the formula. Then it says plus AB. Well, if A is just A, the A to the third is just A, B is 5, so it'll be 5A. What I just tell students is like, just multiply. The middle part is always just like whatever you have here and here, like times put together, like times together. It's just 5A. If this is minus, it always goes minus plus plus. So if you just know the signs, you just memorize how the signs go. If it's a subtraction problem, it goes minus plus plus. And then the last thing says b squared. The last thing in this formula over here says b squared. So it's just like, what's 5 times 5? So the last part's 25. 5 squared, it's 25. That's the answer, you guys. That's how you factor a difference of cubes. Sum and difference of cubes. This one's a difference. It's just learning that pattern that's off to the side. I know it's kind of weird. I know it's kind of weird. It's just like you were given a problem like this, like I have highlighted in yellow, and you broke it into this big green thing. It's weird, isn't it? Okay, one more of these. So instead of like A this time, it doesn't just say A this time. You have to think of these like, the formula says like A to the third plus B to the third. So instead of A to the third, I have this 16S to the fifth. Oh, it's not even to the third. I got a problem. So maybe there's a greatest common factor first. And then we'll think of the problem, how it goes with sum of cubes. Yeah, I think there's something that you have to take out first. Because like it's not matching up like A to the third power. It doesn't say third power. So what do you think? What's the greatest common factor? Yeah, they both say S. They both have a lot of S's. Is there a number you can divide them both by too? They might have something you can divide them by. Yeah, I think you have to divide these by 2 to make this work. See, greatest thing they have in common. So we're going to divide by 2s squared. So if I divide by 2s squared, what do I have now? 16 divided by 2. 8s to the third plus what? 27. Good. Okay, so now this thing right here, this here, that's a sum of cubes that we have to break into this. So this 8, this number 8, s to the third, you have to figure out what's the cubed root of that. You have to break it down so you just know what a is. Do you know what the cubed root of 8 is? Yeah, 2 times 2 is 4 times 2 is 8. It's 2s. And what about 27? What's the cubed root of 27? What times what makes 27? Yeah, it's 3. You can just use a calculator. Or you could look, I can do it like a tree. 9 times 3 is 27, then 9's 3 and 3. See, I can see 3 3's make 27. It's 3. 3 of them make 27. So this is this 2s, that's like the a in the formula. That'll be the a part of the formula. And this number 3, that's b. That's like a and b. So every time you see a, we're going to put in a 2s. And every time you see a b in the formula, you put a 3. See, it's just different, like you have a's and b's instead of... The formula's written in a's and b's, and you have to figure it out. So, we almost got it. So what do you think? So, first we took out the 2s squared. Okay, we already did that. Now I'm breaking this 8s to the third plus 27 apart using this little formula. So the formula says a plus b. So what should I put? 2s plus 3. See, we found, like, we took the cubed root of that, we got 2s. We took the cubed root of 27, we got 3. Yeah, so it's 2s and 3. Okay, now the next part is like a longer parenthesis, 3 things in this one. It says a squared. So this is like your a. You square that. Like, what's 2s times 2s? 4s squared. It's like 2 times 2 is 4. It's not that bad. Okay, now the middle one, the second part, it says AB. You know, this was A and this was B. Could you just times that together? Put those together, what do you get?
6s.
Yeah, it'd be 6s. Good job. And then finally, the last part says B squared. Well, our B number was 3. What's 3 squared? 9. That's the answer. Got it. That's the answer. It's weird, isn't it? It's just like following a pattern, though. Like 2 times 2 times 2 makes 8. 3 times 3 times 3 makes 27. So it's 2s plus 3. Usually I just look at this and then I'm like, okay, I got to square this thing. I have to square this, like 2 times 2 is 4. And then the middle one is just this one times this one, so it's 6s. And then the last part's 3 times 3 is 9. Yeah, when I'm doing them, I just kind of look at what I had to start, and then I square that, times them together for the middle, and square that for the last. You'll get used to it if you practice it a few times. I put a quizzes on Canvas that you can practice these, the sum and difference of cubes, like off the computer. You should be able to like look at them and be like, oh, it has to be that one. Because yeah, it's like a little problem, something to the third power plus something else, and you have to break it into some long thing. And then finally, we'll do factor by grouping, and then that's kind of where we'll stop. And then you'll practice some on a worksheet. But yeah, I put a quizzes on here too for you to try as part of your like assignment. Try, because like repetition, you know, practicing on a computer, you'll be like, oh, I see, it has to be that one. You'll start figuring out the patterns to it. Okay, finally, factor by grouping. Look for 4 terms. That's how I know that's how you'll know, like, oh, I have to do the factor by grouping on this. I see 4 things. If you see 4 things in your problem, it's usually factor by grouping. So I see x to the third, 5x squared, minus 4x, minus 20. 4 things. When you do factor by grouping, you just look at sometimes people draw a line in the center. It's like you just look at the first part. You pair it up. Like, what about these first 2 things? And its greatest common factor again. You think about, what do these have in common? So look at the first pair of items in this problem. Do they have anything in common? Right, x squared. So we take out x squared. So if you divide by x squared, what would be left? Yep, good, x plus 5. Now look at the second part of the problem, the second half. What do you see in common of those? Yeah, these can divide by -4. And if you see that both of them are negative, if you see negatives, a lot of times you do want to divide by the negative also, like -4. So if I divide by -4, what do I have left? X plus 5. Now, you should notice that these match. That's what should happen in factor by grouping. If these don't come out matching for you, then maybe you didn't get the greatest thing taken out. Or maybe you forgot to divide by a negative sign. Like, that's why I was saying divide by negative, because I knew I wanted to turn it to plus so it'd match this one. These have to match on factor by grouping. And then you write the answer. These go together. This is kind of interesting. Then you like put this, you put those things you took out of each one, the greatest common factors, you put those together. It's x squared minus 4. You put those little items you divided each thing by, greatest common factor, you put that together. And then you put these matching things, you put that in this one, x plus 5. You don't have to write it twice. It's kind of like a little trick. You make it into a FOIL problem so you don't have to write it twice, because if you distributed, you'd take x squared times both of those, then you'd take -4 times both of those. So you don't have to write x plus 5 twice. It condenses it. And then actually, I have one more step on this one. Sometimes you're done after this, sometimes you're done. But I think I'm not done because I see another thing that we can factor. It's not done. You can factor one more time. Do you see something you could factor? This x squared minus 4, that's a difference of squares again. The x plus 5 part's done, but you see how that's a difference of squares? This doesn't always happen. Sometimes you're done after that step. Sometimes you're done here, and it just is like, okay, that looks good, I'm done. But if you see a subtraction and one of those perfect squares again, that's a difference of squares. So how does this work? Yeah, x minus 2 and x plus 2. Now it's finally done. So factoring can be tough because there's multiple things you have to check for. That doesn't always happen. Sometimes you're done right here at this step, but sometimes there's a difference of squares or something that can go again. Usually you're done though after the factor by grouping first part. Alright, so we practiced a bunch, getting these notes helps, so hopefully you understand it.